So I wanted you guys to try a problem. And the problem I want you to try is number 7. I'm pretty sure I copied this from some open source textbook, so we didn't violate any copyright rules. Let me add on a page here just to give us more room. Okay. So I think the first thing you should do is try to draw a general schematic of the diagram. Okay, so label what's changing, draw a sequence of pictures or a bunch of lines or whatever. Try to translate this information. And then I'm going to check in with you in a few moments. So I want you guys to try to unpack this as much as you can. This one involves a model that you've seen before. So, give it a shot. I mean, eventually I'll do it for you, but 2 planes are flying in the air at the same height. Airplane A is flying east at 250 miles per hour. When you guys look at this, I hope you have a bioreaction. I hope you're like, oh, that's a rate. And the top is a unit of length and the bottom is a unit of time, right? So this is a rate. Plane B is flying north at 300 miles per hour. This is also a rate. So they're giving us 2 rates. If they are both headed towards the same airport, located 30 miles east of airplane A and 40 miles north of airplane B, at what rate is the distance between the airplanes changing? Okay. So if I were to draw a sequence of photos, I think my very first picture would look like this. Or you know what? Let me, so some people like multiple drawings and some people like one drawing. I don't know which one you prefer. Maybe I'll draw multiple drawings first, and then I'll try drawing one drawing next. So I guess my first drawing could look something like this. Right? Here is A. Here is B. The initial drawing, this is 30, and this is 40. And here's the airport. But then this plane is flying, A is flying east and B is flying north. So a little bit later, I think my picture probably looks like this. Here's the airplane, but this triangle now becomes smaller. And then a little bit later, it becomes even smaller. Does that make sense to you guys? So if I wanted to do it all on one diagram, I could sort of go, oh, well then maybe the next triangle looks like this. Maybe the next triangle looks like this, something along those lines. And your A is changing here. So this is A, this is A. That A is moving east. And this B is moving north. Now, if you look, I didn't make these guys I didn't make these guys equally spaced. That's just a minor detail. The reason why I didn't is because plane B is flying faster than plane A. So the shape is going to fundamentally change. They're not moving at the same rate. The plane is flying north is moving faster. I kind of try to represent that. It's not essential. Does anybody have any questions about understanding how the situation is changing? You could unmute yourself and ask. All right. Let's see if we all have the same schematic diagram. For your snapshot photo, did you guys all draw a right triangle? It looks like this, something like this. Did anyone come up with a good label for this side? I mean, I would call it X because it's a horizontal thing. That's clearly a variable, right? What about this side? Is that a variable? Yes. It's a vertical thing. I call it Y. Is this length changing? Look at this diagram. Is that length changing? Yes. So you got to give it a letter. Let's call it Z. This is that snapshot drawing that I'm talking about. All right. I have no idea if you guys understand what I'm saying. So let's play 3, 2, 1, go. If I ask you what's dx dt, I want you to tell me. So take a second to think about what dx dt is in the context of this drawing. And then we're going to type our answer in the chat box. So type your answer if you have one. And then let's count it down. Ready? 3, 2, 1, go. All right. Not gonna lie, I see 4 answers and none of these answers are correct. Of these 4 answers, I would say I like Simon's the best. Steph, it looks like you're trying to do a Pythagorean theorem type thing. The Pythagorean theorem type thing looks like lengths to me. It doesn't look like a rate of change. Dx dt is a rate of change. So I don't think your answer would be correct. I highlighted 2 rates of change. So you would think it would be one of those 2. So a lot of 3 of us wrote 250 miles per hour. I told you that was not correct. It's mostly correct. Can anybody see what the error is? Like Michelle, can you modify your answer so it's correct? Reagan, can you modify your answer so it's correct? Simon, can you modify your answer so it's correct? You don't know what I'm talking about. I want to tell you, but let me look back at our previous example. Why did I have the volume be negative 0.03? Ah, Desmond, you see, because it's decreasing, right? The volume is getting smaller and smaller. That's why the dH dt was also negative, because the height is getting smaller and smaller, right? So when I look at this picture, is the X value getting bigger and bigger and bigger? No, it's getting smaller. So this should be negative. Does that make sense? Any questions? All right, no questions. I think the next one will be easier. What's dy dt equal to? You can just I hope this is obvious, right? It's negative 300 miles per hour. Again, this y distance is getting smaller and smaller. And then we got to ask ourselves, what are we looking for? And the thing that we're looking for is we're looking for dz dt. So that's the rate that we're looking for. Okay. So I have my schematic, my snapshot picture. I've labeled all the variables. I haven't used the fact that the original shape had 30 miles and 40 miles yet. But as we all know, eventually you have to plug numbers into your related rates equation. So now that I've got the entire setup done, I need to relate the variables. Steph, do you see what relationship exists between the variables X, Y, and Z?
Yeah. Pythagorean theorem.
Pythagorean theorem, that's right. Would you mind telling me exactly what to write, please? Involving X, Y, and Z?
I'm not sure if we're supposed to use the -250 or
No,
30.
that's a rate. Pythagorean theorem just relates the variables. So we're going to use implicit differentiation next to involve these guys. So just forget about this right now. Just what's the relationship between these three variables?
X
Does anybody want to?
squared plus y squared equals z squared.
Correct. I'm going to write it as z squared is equal to x squared plus y squared. But your answer was the same. I only put it this way because I know I'm going to solve for dz dt. So I like to have my z on the left. Okay. Any questions? Okay, next, I want to relate the rates. I've got to use implicit differentiation. Or the chain rule, it's the same thing. So this is going to be taking the derivative of both sides with respect to t. I want to call on someone to help me out here. Michelle, you willing to help me out? What's the derivative of the left-hand side? Any thoughts? What about you, Reagan? You have any thoughts as to what the derivative of the left-hand side should be?
2z dz over dt.
Oh man, you left me hanging there for a second. You were like the dramatic pause. I was like, oh no, do I have to ask him? Is that your final answer? And then you correctly used the chain rule. That's why I call it implicit differentiation, right? In the past, when we took the derivative with respect to x of y, you get dy dx. If you took the derivative with respect to t of y, you would get dy dt, right? If you differentiate with respect to tz, that means you get dz dt, right? These are all like treating each of these functions, each of these variables as a function in terms of x, in terms of t, as I've written it here. So we have to realize that z is changing as time changes. So we have to use the chain rule. And we did. All right. If you understood that, then you guys should be able to do the right-hand side. So I'm going to give you a few moments to finish this off. Try to finish this problem. In other words, finish the derivative, solve for what you're looking for, plug in the numbers. I'm going to give you, let's do 4 minutes. Give you 4 minutes to try to figure out how to solve this. And then I'll help you next. 4 minutes.
Professor,
Yep,
why are we not differentiate the y square?
you do. I'm taking derivative of both sides.
Oh, I see.
All right. Hopefully you made some progress. Let's take the derivative of the right-hand side over here. Desmond, do you know what the derivative of the right-hand side is? Or can you tell me what you wrote, sir? Perfect. That is exactly correct. 2x times dx dt plus 2y times dy dt. I think that looks great. We want to solve for dz dt. So we're going to multiply both sides by 1 over 2z. Like that. And then the next line we're going to get dz dt is equal to 1 over 2z times 2x dx dt plus 2y dy dt. That's a z, not a t here. So one thing I could do is I could take this 1/2 and I could distribute it inside the parentheses like so. So then this makes my thing 1 over z x times dx dt plus y times dy dt. And that's my dz dt. Now I know I want to evaluate it at a point, and the point I want to evaluate it at is going to be 30, x equal to 30, y equal to 40. So I'm going to have x equal to 30, y equal to 40. So I'm gonna have 1 over z. This will be 30 times, what was this? Negative 250 plus 40 times negative 300. Now, I almost am done. The problem is I have this variable here. I have this z variable. Can someone unmute themselves and tell me, how do I find z? How'd you get 390, Reagan? Anybody have any thoughts?
Pythagoras.
Yes. So I think what we need to do is we have the Pythagorean theorem. This side is 30, this side is 40, this side is z, right? So that means z squared is equal to 30 squared plus 40 squared, or z is equal to the square root of 30 squared plus 40 squared. So in the end, my answer is going to be 1 over the square root of 30 squared plus 40 squared times 30 times negative 250 plus 40 times negative 300. And then your final units will be in miles per hour, because that's what they gave us. So if you had a calculator, you could calculate what number this is. The nice thing about standards-based grading is if you get this far and it's correct, you're going to pass the standard, you know, and there's no difference between a 3 and a 4. So it's easier for me to grade when you get the right final number, but I can look at this and tell that you know what you're doing. Any questions about this example, my friends?